So here we are doing, we are sending the signal and we have a band fast, tunable band fast filter, and we have a power meter. Okay. Then what we can do is, so here we have 0 to 50. Okay. Then you are selecting one band. Okay. One frequency. Okay. Actually, you can't very strictly selecting one frequency, but you can get a small band. So that may be 0 to 1 hertz or something, 0 to 1 hertz or something. Okay. Then you can see the power of this one. So you can plot it power. Then you can get another band. Okay. You can get another band. Then you can see the power. You can get another band. Maybe this from 1 hertz to 2 hertz. This is 2 hertz to 3 hertz. 2 hertz to 3 hertz, another power. Okay. Likewise, you can get each. So here we have the frequency, each frequency component, each frequency value. So here you have 0 to 50. Okay. 0 to 50 means from here, 0 to 50. Then you are measuring some power value using the power meter like this. So maybe you can get this kind of spectrum. So here, frequency versus power, you can plot. Okay, if you have these values, okay, in a storage, you can plot this. Okay, you can plot this, and so that is a type of spectrum analysis. That is a type of spectrum analysis. Okay? So that kind of techniques you can use to develop spectrum analysis also. Okay. So I think that is enough related with the instrument. Okay. And so I think that is okay for LO1. Okay. We have thoroughly discussed DC and AC bridge, voltmeter and ammeter. Okay. And we see the some introduction of two signal source and function generator. And also we have still learned the oscilloscope and network analyzer measurement. Okay. So I think that may be enough. Okay. So then we have to move to the learning outcome to analyze the measuring error and improve the accuracy of measurement. Okay. So, uh, so analyzing the measure, actually I will, so there is a corresponding chapter in our reference book. Okay. So that is chapter 1 actually. Okay. So that is chapter 1. Okay. So in chapter 1, we have these things. Okay. So that is the qualities of measurement. Okay. So here the the instrumentation and measurings are somewhat defined and explained what is instrumentation and what is measuring. Okay. So you can read them to understand what is instrumentation, what is measuring. Okay. And also the performance characteristic of the instrumentation is of instrument. Okay. So if you consider instrument, okay, so there are some characteristics. Okay. So there are some characteristics that can be used to measure the performance of the instrument. Okay. Okay. Knowledge of a performance characteristic of an instrument is essential for selecting more pseudo. Okay. So that characteristic maybe you need to use to select the appropriate instrument. Okay. For example, there are two type of characteristic, that is uh, statics and dynamic characteristic. For example, range. Okay. I'm measuring range. It is not here. Anyway, it is not included here, but the range is one very important characteristic. I don't know why it is not mentioned here. Okay. Because for a specific application, you need to understand the range. For example, if you are going to measure uh, uh, 3000 volt istunda, okay, what is that? 33,000 voltage. You should not get a normal voltmeter, no? 230 voltmeter. What happened? You will die, no? Okay. So the range is very important. Okay. So that is one characteristic. Okay. That is one parameter, range. Okay. And there are other parameters also, that is accuracy. Okay. So that is the degree of exactness of the measurement compared to expected value. Okay. I will explain it. Okay. And the resolution is also another very important. For example, I told you that related with the analog to digital converter, resolution is the resolution give us the number of bits to represent the voltage value. When the resolution is high, we can we can we can we can uh, we can detect very small voltages also. Okay. So resolution is also related with the smallest value we can deal with. Okay. The smallest change actually in the measured variable. Okay. And precision is also related with the accuracy. Okay. Uh, I will explain it a little bit later. Okay. And I think you know what is expected value. Expected value means the mean. Okay. So uh, uh, so maybe that is a statical what an expected value means. Okay. So if you have any variable, okay, so expected value is referred like this, ex. Okay. Uh, Actually, there is a definition for this one. Okay, for the expected value. Uh, so it is related with. So this should be a random variable. This should be a random variable. I think you know what is random variable. Okay. So random variable means that is not a deterministic value, it is varying. Okay. So there are different type of random variables. Gaussian random variables. Then what are the I can't remember. Gaussian, then binomial, then um, there are many type of random variables. Okay. So that is related with the probability distribution of the random variable. Okay. So based on the probability distribution, these random variables we can categorize into many types. Okay. For example, Gaussian, binomial, likewise. Okay. So expected value is actually related with uh, random variable. Okay. So random variable also can be classified as continuous and discrete. Okay. So if you need to get the uh, expected value of a continuous random variable, you have to do a integration. I can't remember the exact equation, but internet we can see. Okay. So as I can remember, it is like this. Okay. If we want to get ex, okay, we need to integrate this from minus infinity to plus infinity. Uh, our variable x into this the probability distribution px dx as I can remember. Okay. So this is the way to calculate the expected value. But once it come to a discrete value, this is for continuous value. Once it's come to discrete value, so this integration will become summation. Okay, summation x px. Okay, this is a probability. Okay, it is from final minus infinity plus infinity. Let's see, I can't remember it's clearly. Expected value, expected value formula maybe. This is a mean. Okay. I told you that is a mean. Okay. Okay. So this is for uh, discrete variable xpx, x into probability. Okay. And for a continuous value, it should be an integration. This one, yeah. Expected value formula for continuous value, maybe discrete random variable. Yeah, Poisson, another type of random variable. Exponential distribution, that is another type of random variable. Normal distribution, that is a Gaussian one. Uniform means the probability is uniform, no change. Okay, so that is uniform distribution. Binomial distribution. Okay, so there are many type of one. Okay, expected values. Yeah, this one. Okay. So it is from minus infinity to plus infinity xpx. So this is the expected value. Okay. Then variance means you have to get the x square. Uh, Minus mu. Okay, so maybe we can write this like this actually. Okay, the variance means, okay, the variance means you can calculate the expected value x minus mu square. This is the variance and it is from minus infinity to plus infinity. So you have to get this one, mu square pxx. Okay, so this is the variance actually. Okay. So that is one. Okay, so that is one. Okay, so actually we are dealing with discrete values. So don't worry, we no need to do we no need to do any integration. Okay, so for expected value, for example, if we have, let's say that if we get some voltage measurement, okay, voltage measurement, we have, there is a battery. Okay, so we measure the battery voltage using a voltmeter. Okay, so let's say that we have measured it 10 times. So we get, first time we get 5, then we get 4, 5, 4, 4, 3, 2, 5, 5, 3, like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we get 10. Okay, then what is the probability of having 5? Now 1, 2, 3, 4 are there. Then 10 into 4, that means 0.4 probability for 5. 4, 1, 2, 3. That means 0.3 probability. Okay, 5 again, 4 again, 3, only 1, that means 0.1 probability. 2 is there, 2, that means 0.2 probability. Okay, so these are the probability. 5 probability is 0.4, 4 probability is 0.3, 3 probability is 0.1, 2 probability is 0.2. Okay, so once you add these things, 0, 4, 0, 4, 0, 7, 0, 8, 1. Again, you should have 1 because the addition of the probability should be equal to 1. Okay, so these are the probability. Then if you need to find the expected value, what you have to do, you have to get the summation x, that is the variable, and px, the uh, the the probability. So this is the variable 5 into 0.4 plus 4 into 0.3. This is the variable probability. So summation, you have to get the summation. So you have to get sum plus 3 into 1 plus 2 into 2. This is
ස්ක්‍රීන් එක පොඩ්ඩක් පේන්න.
නොමට කියප ටික තේරුණා? දිගටම මේ වෙලාවට තිබ්බේ.
දිගටම නෙමෙයි සර්.
හ්ම්?
පල්ලෙහාට එකක් තියෙනවා සර්.
දිගටම මේ වෙලාවට තිබ්බේ කොල්ලෝ?
නෑ සර් මේ අතන මේ
කොයි හරියද?
ඉන්ටග්‍රේෂන්
ඔව්.
අන්න එතනින් පස්සේ හරි දැන් හරි සර්.
හරි ඉන්ටග්‍රේෂන් එක එහෙම දැක්කනේ නේ?
ඔව්.
එතකොට ඒක තමයි අර මේ වේරියන්ස් ගන්න හැටි. හරි ඉන්ටග්‍රේෂන් එක දැක්කනේ. එතකොට මෙතන දැන් මම ගත්තේ මෙහෙම if we take a volt, if we consider battery, we are going to measure the voltage between this battery. Okay, So we get a 10 voltage value. Okay, so we get different value. Okay, so that is normally happening because these voltmeters are not perfect. Okay, so time to time the measuring value may be changed. So we will have random values. Okay, so let's say that we have this value 5 4 5 4 4 3 2 5 5 2 5 4 3 2. So these are the voltage value. Okay, so 5 we have 1 2 3 4. Okay, that means we have five values. There are 4. Okay, that means 10 out of 4 5 values. So that is the probability 0.4. The same way we have 3 fours. That means 10 out of 3. So 0.3. Okay, and 3 only 1. 10 out of 1 0.1. Is a two twos are there. So that is 10 out of 2, 0.2. These are the probabilities. Okay, so this is the variable, these are the probabilities. And to calculate the expected value, you have to get the summation of the variable and the probability. So this is the variable 5 into 0.4 plus you have to get the summation 4 into 0.3, 3 into 0.1, 2 into 0.3. So you can calculate the expected value easily. Okay, so actually you can see that the same value you can get, okay, you can get by adding all these value 5, 5, 5, 3 plus 3, like this, divided by 10, the number of samples. Again, this is equal to the expected value. Okay, so this way or this way you can calculate the expected value. This is the mean, no? Make a mean negative. So you can calculate the mean. So that is the expected value. Okay, and error we have to define, sensitive also we have to define. Okay, so here there is another terms called absolute error, that is E. Okay, so absolute error means the value we get, this is the absolute error. So this is the real value we get and this is the expected value. Okay, so if you consider absolute value here, so expected value is, so you will have a value for expected value here, and absolute value, so the real value is 5. So 5 into expected value, that will be the absolute error. Okay, so that is the absolute error. Okay, then absolute error divided by expected value in, and if you get the 100%, that is called percentage value. So absolute error is there, percentage value is there. Okay, you have to learn these terms. Okay, so percentage value you can easily calculate. And the accuracy means 1 minus error. 1 minus error, that is the accuracy. 1 minus error. Okay, so if you get the percentage, okay, 1 minus percentage error, that will be the percentage accuracy. Okay, so here you have a example. So the expected value is 80, the measurement value is 79. So you can calculate the absolute error, that is the real value is 79. Okay, the expected value is expected value minus measured value. Okay, here the expected value minus measured value. So expected value is 80, the measured value is 79. So your error is 1 volt. Okay, so then 1 volt is divided by the expected value, that means by 80. Okay, then get the 100%, it will be the percentage error. Okay, then relative accuracy means 1 minus uh, uh, 1 minus the error. So this error is not the percentage error. Okay, it is not the percentage error, just the error. Okay, absolute error divided by the expected value. If you get the percentage, that is called percentage error, this one. Okay, but here you get only the error. This is called relative error actually. Okay, so 1 minus relative error, it is called as relative accuracy. And if you get the percentage, it is the percentage accuracy. Okay, So these four terms maybe you can calculate easily. So there are many examples you can identify. Okay. So here, this is another one. Okay. So here the measurement numbers are there. Okay. So these are the measurement value. Okay. How many measurement? 1, 2, 3, 4, 5, 10 measurement. Okay. So if you add all these values and divided by 10, you can get the expected value or mean. Okay, so that is the mean. Okay, so you can calculate the mean. The same way you can calculate the absolute error. Okay, so if you consider this term, you can, relative to this measurement, you can calculate the absolute error. So this is the real real value you get. Okay, so absolute, the expected value will be this one, or sum of the 10 measurement and divided by 10. Okay, and you can calculate the measured value related to this one. Sorry, the absolute error related to this one, and also you can calculate the accuracy, relative accuracy, percentage error, anything. Okay, so precision is also defined here. So you can see that precision is also related with error accuracy. Okay, so this one is also just like the accuracy, the same equation is there, but this is referred to some specific measurement. This precision is always referred to specific measurement. Okay, not the general measurement. For a specific measurement, we take the precision. Okay, the precision. So you can see that precision and accuracy, read this one. Okay, so try to understand that terms also. Okay, so accuracy or precision, just like the same thing. Okay, so it gives us the quality of the measuring instrument. Okay, okay, so those are the statics characteristic. Okay, so you need to study at least this absolute error, expected value, then expected value, absolute error, relative error, percentage error, relative accuracy, percentage accuracy, and precision. Okay, so we will stop from here. Okay, and last time, next week we will try to understand this. These are type of statics error we can see. Okay, static error. Okay, maybe try to maybe you can understand this by yourself. Okay, so try to do this 1 or 2 example. Maybe you can understand the simple things are there actually. Okay, so try to do this one. Maybe within next week we will try to finish this part, the quality of the measurement. So that is related with the LO1. Okay, LO2. So for the LO3, actually we have to design a simple measuring instrument. Okay, so there we have to learn this kind of things. Okay, I will put a video. I have already recorded video for these terms. Okay, so I will upload that video for your reference. Okay, so that is all the lectures related. So from next week we can finish all the lectures related to this all LO3. Okay, LO1, LO2, and LO3. Okay, then I think we don't have time to design a measurement instrument. Okay, measuring instrument. I will check this with Dr. Nikolai. That is your head now. Okay, so if we said that we can just skip this, we can skip, no problem. Okay, otherwise then you have to do a simple design. Okay, okay, so we will check it. Okay,
Oh,
okay, anyway, I think you can't mark the attendance, no?
Yes, sir. I informed Mr. Luksh about that.
Oh,
I will check again.
oh, okay, no need actually. Dr. Nicola, I know that you have. Um,
Uh,
so can you tell me your name, please?
Name Charit Udayang.
What is the name?
Charit Udayang.
Charit Udayang, no?
Yes.